Dude, I just want to say, I hit the record button. Like, I hit the record button. I thought I did. I didn't. And I just recorded basically the video that, like, this whole thing. And, okay, I know what I want to say now. Say though. So, we got it down. So, limits. Let's write one down. Limit of f of x as x approaches. Okay, let's not use f of x. Let's limit of x approaches. Limit as x approaches to of 2x, basic one. When it's really basic like this, when it's straightforward, basically if you can replace two directly with x without any problems, then you should do that. So the limit of that would be obviously 4. You know, that's like okay. Let me explain what a limit is. Limit is what a number is what a function is approaching, or what f of x is approaching when x gets close to a certain value. So, of course, let's look at this example. This is f of x equals x, you know, easy line down there. So the limit as x approaches 2 of f of x would be 2. And you can see that right here. Look at the line here and here. It's approaching that value right there, 2. Now you might be wondering at this point, what's the difference between f of 2 and the limit of f of x as x approaches 2? To put it in words, with limits, you're finding what it's approaching. Let me draw the arrows. Limits, you're finding what it's approaching. You're finding that area right there. But with like f of x, you're finding the direct value. To kind of put that in a perspective, we have this right here, piecewise function. We'll see here. Okay, let's look at this actually. Notice this. That means x does not exist at that specific point. But so f of x at x equals this point wouldn't exist, but the limit would exist because we're still approaching a singular point. For a limit to exist, it has to be approaching a singular point from the left and right. Now for notation, look here. Minus means coming from the minus area, like from left to right, and then like here, and then plus would mean from right to left, from positive right here. Now if we look at this specifically, this one, I circled it earlier. I can't like undo it because it was way back, but we look at it. Notice how from the left, wait, let me write these down. From the, coming from minus, it's up here at x equals 1, it's at equals 4. From the positive area, it is negative 3. So that means the limit itself, notice, look, if it doesn't have, if it doesn't have the plus or minus, then it's just simply what it's approaching, the limit itself. So here it would not exist, d and e not exist. But f of 1 would exist because right here, that's where it is. That's what f of 1 is. So, okay, I got confused with this when I first did calculus 2, because calculus, comma, TOO, because I've never seen a piecewise function in my life before this. Okay, that's an exaggeration, but yeah. So, basically the holes are these values, like right here. Those don't exist. Those aren't real. Like, those don't exist, but these exist. So if there's holes here, but this exists, that means there's an f of x. But if these are separate, that means that because the limit has to be approaching the same value from both sides in order for it to exist. Now for here, let's look at this. The limit exists, but f of x does not exist because right here there's a hole. Now, if there was a dot here marking, f of x, or like where it exists, then the limit would exist at this value, but f of x itself would exist at this value. So important to keep in mind. The word approaching, is important because that is a perfect description of what the limit does. It's approaching a value, but it's not the value itself. Let's solve a quick problem over here. So the problem would be limit as h goes to 0 of -4 plus h, -4 plus h in parentheses squared minus 16 all over h. So notice h goes to 0. If we were to use direct substitution here, we can't because h is on the denominator and we can't have 0 on the denominator. That also means that if we were to just do f of 0 for this function, it would just not exist, the any. But let's try and get the limit. Now, if you can't use direct substitution, then you gotta do some math. So -4 plus h squared, -4 plus h times -4 plus h, so h squared. Okay, limit of h goes to 0. Another thing to note is, for proper notation, there's no equal sign here, because it's all just grouped together. So pretend there's an equal sign here. There we go. H squared plus 8h, I think. Oh, minus 8h. Is it minus 8h? Yeah, minus 8h plus 16, minus 16 from earlier. And then all over h. Now we take those out. Forget about that. Look at this. H squared, 8h. Take out an h. Lim h 0. H minus 8 over h. Take that out. And then the limit of h goes to 0 of h minus 8. You can take the limit now. You can substitute it right now. So, h squared. My apologies. Okay. H squared. Apologies. 0 squared equals 0. So we're left with -8 as the answer for that. So the limit as h goes to 0 equals -8, and f of 0 in this case would equal d and e. Important thing to note there. Not important, but something to keep in mind. Now for this here, it isn't really it doesn't fit to talk about the derivative right now, but this is the limit definition of the derivative. F of x plus h minus f of x all over h as h approaches 0. Now what this does is it finds the slope of the tangent line, of the line tangent to f of x at a certain point. So I'll use this right here. We use this point right here. Let's pretend that this is its own thing, and it's not crossing here, because then it wouldn't be a tangent line. But look at here. Notice this line, that would be the tangent line, which means it only touches enjoying calculus recently. But yeah, if you guys want to watch any, or if you guys want any more explanations about certain concepts in calculus, just let me know. I know stuff up to, okay, I'm taking Calc 1 right now, so I don't really know that much. But I'm taking, what I know right now is up to like the chain rule. So anything in between limits up to the chain rule, I got you. So if you want to know a specific thing, specific topic in calculus, or if you just want to know another thing, if you want me to talk about calculus again, just let me know. But yeah, thank you for watching, really. I know it's been a while since I've posted. I got busy. I started going to the gym, and I had a family trip. So, like, and that messed up. Going to the gym basically just messed